So our next talk for this session and the last talk for this session before morning tea is by David Lowe and is on building the next generation conversational AI with Python and deep learning. David has come from Singapore, where he is the founder and chief scientist of a startup called Pand.ai. David's background is in a range of data science and AI technologies. He represented Singapore and the National University of Singapore in the data science games last year, clinched top spot amongst the Asian and America teams there. He's been a guest lecturer at universities. He has worked with in research projects with universities like Carnegie Mellon and MIT. For fun, he competes on Kaggle and is ranked in the top 0.2%. He's also an avid Python developer, which is good because we are at a Python conference. And so he's here today to talk about AI chatbot technologies and how that fits into deep natural language processing. David, it's all yours.
Hello. Thanks, Graham. Is it okay? Yes, it's okay. Okay, a very good morning. I'm David from Singapore. So this is my first time to Australia, and this is my first PyCon AU. So great to see you guys. Okay. So for those who read my abstract for the talk, right, I actually made some changes to the content to cater for the timetable change. But in fact, I thought the talk is only like 15 minutes, but I realized it's 25 minutes. So I guess we could have a longer Q&A sessions. Yeah. Okay, so in this fast-paced world, customer very often they demand efficiencies when they are trying to talk to the company. So very often we see like customer complaining on the social media that they have been waiting on the phone for like 30, 45 minutes trying to get to talk to the customer service. So here come chatbots. Chatbot is an automated conversation agent that helps company to communicate to their customers via voice or text. And the main purpose is to streamline the interactions between the people and the chatbot around the clock, so it works 24/7 without any break. So chatbots are beneficial to both parties, the customer and the company. So because it's cheaper to develop a chatbot compared to train a humans, and it's more scalable. So once it's trained, you just can leave it there, and through machine learning, you get better and better when it has talked to more like customer, gather more conversation history. Okay, so from Apple Siri to Amazon Alexa, so we have seen this chatbot everywhere. However, there are plenty of so-called the dumb chatbots in the markets, so that which utilize more straightforward approach like pattern matching or rule-based approach. So today I will share something about building the so-called the next generation's conversation AI using Python and deep learning. Yeah, so this is the overview of my talk. Today, so just now I share about the current state of the conversational AI. And I will talk about initiative from Facebook. In fact, from the FAIR group, the Facebook Artificial Intelligence Lab, which is about the dialogue research platform called Parlay. Then I will show a demo of a question answering systems, followed by something that caught in the news recently about Facebook research. And lastly, we'll share about what we learned as Panda in Singapore after we launched 2 chatbots with 2 big clients, enterprise clients. Yeah. So, okay. While Siri, Alexa, and the likes can follow simple spoken or typed commands and answer basic questions, obviously they can't hold conversations like a human and have no real understanding of the words they use. And this is from Will is the senior editor from MIT Technology Review. Basically, yeah, it shows the current limitation of the technologies when it apply to chatbots, most of chatbot in the markets. Okay, so sadly, most of the chatbot available on the markets are actually a glorified IVR. In case you have no idea, IVR stands for Interactive Voice Response System. So these are the systems that when you try to call the bank, then you press 1 to ask about credit card, press 2 about banking. So in this case, the chatbot doesn't really understand natural language. So, and it is programmed to execute a certain, depends on the user action. So we want you to press on the button, try to book a test drive, but you just couldn't understand, like, show me your latest model. Then it prompt you to give a start command. Again, then lead you to book a test drive. And the second example is, yeah, no matter what you type, we just keep prompting you to fix storyboards or guided conversations. So these are the bots that couldn't handle much natural language. So you just keep pushing up buttons, ask you to react to the buttons. So, okay, moving forward, right? Facebook has released these dialogue research software platforms, and the logo is a parrot. The name is called Parley, and it's developed in Python. So the purpose is to provide an unified framework for training and testing of dialogue models, so that to enable chatbot to converse better compared to the chatbot you have seen just now. So the grand vision is to enable more systematic developments and evaluations of dialogue agents, help push the state of the art technology in dialogue further, and benefits the field as a whole. So while it's not what I call a technology breakthrough, it's definitely a great initiative to standardize the dialogue research. So here are the few of the main features. So it has these integrations of Amazon Mechanical Turk, and it supports multitask training, which we'll be elaborating more about multitask training. And it has a built-in data set for over 20 tasks, which I will be sharing more later. Okay, and you can find more information on parl.ai, it's an official website. Okay, so this is the live chat interface they built in the Parley platforms. So over here you can see there's this user interface allows the researcher to provide a short passage or content. Then you ask the humans to provide questions given this context. And then you ask again the same agents, the humans, to give answers. So through this way, they are trying to gather data. In fact, right, no matter what you're working on, like machine learning, deep learning, the most important thing I would say is the data. So without data, you can't build any machine learning model. And we need high quality data because, as the saying goes, rubbish in, rubbish out. You can't expect a machine learning model to generate insights from noisy data. So an important part of Parley is the seamless integrations with the Mechanical Turks for data collections, training, and evaluations. So this interface shows the data collection part. In fact, they also have this evaluation part where they ask the humans to rate the answers given by the model. So in this case, they can use that feedback to further improve their model. So the human Turkers in this case are also viewed as agents in Parley's framework. So like person-to-persons dialogues, persons-to-bots dialogue, or even multi-people and bots in a group chat context can be realized in this framework. Yeah, so all these rows can be switched without code changes in the code changes to the agents. Okay, so the conventional machine learning approach, right? Usually we will pick a particular metric to optimize. Let's say I want to do a regression, predict a figure. I will use root mean square error, RMSE, or I want to do a classifications problem. Then maybe you pick AUC. So conventional machine learning approach, we try to optimize for a particular metrics. And usually what we do is we train either a single model, or we train an ensemble of models of multiple simple or single models. Then we fine-tune that model or those ensemble model, and tweak parameters to try to achieve the highest score in terms of that matrix we identified just now. So for multitask learning, multitask learning is also known as dry learning, learning to learn. Actually, in fact, it's not a new concept. It has been known for quite a while. Okay, so what differentiates multitask from conventional approach is it optimizes for more than one loss functions. Then you can consider as a multitask learning. And why? Why we need multitask learning? Okay, so it helps by improving the generalizations and by leveraging on the domain-specific information contained in the training signals of related tasks. So yeah. So why we need generalizations? So because it prevents overfittings. So it reduces the overfittings of the model against the specific data set we are working on, and encourage the model to perform something called task transfer. So we learn across different tasks and gain more insights compared to just focus on one task and learning on the same data sets. Okay, so here are the 20 data sets included in the Parlay platforms. So we have QA is question answering data sets. This is from Stanford, and for this one is simulated data from Facebook with BA tasks. Then we have some other tasks like goal-oriented dialogue, some other data sets. Then we have sentence completions data sets, and this is just a dialogue chit-chat data sets, which have something from the Ubuntu open forums. We have movie subreddit Reddit dataset under the movies, and even like open subtitles datasets. So you have the subtitles from all the movies. And lastly, we have the visual QA, which basically have dataset related to images or media. Yeah. So what we can do with all these datasets? These datasets are being organized into 5 categories, each correspond to the task. So question answering is the simplest form of dialogue. So every time I ask one question, and the bot get back with one answer, then I follow with another questions. This is the simplest form. And we have the sentence completion, which also known as the clause test. Basically, given a sentence, try to fill in up the missing words. Then we have the goal-oriented dialogue, which, so what this means is usually maybe, for example, I have a movie booking bot, so the goal is to have the customers book a ticket in the end. Then we have chit-chat, just dialogue without specific goal, so it's like more of a discussions. Then we have a visual dialogue, basically try to ask questions, answers questions based on the image or the media they provide. Okay, so yeah. So we have worked on something on the question answering. So yeah, let me bring up the demo. Oh, first, let me introduce the data sets I'm working on. Let's see. Okay, Squad is actually a open source question answering data sets from Stanford. Okay, so this is the website. You can download the data sets here, and there's a leaderboard that you can submit basically submit your model, and you can see like how well your model performs against other model from other research institutes. So let's just look at the data. So yeah. So okay. So right now they have 100,000 articles, and maybe you can just click goes to one of it. So these are basically a short passage extracted from Wikipedia. In this case, it's about Nikola Tesla. So and this is the labeled data done by humans. So for example, I have these questions. In what year was Nikola Tesla born? And the answer is 1856. Okay, so basically the humans ask the questions, and the humans help to label the answers from the passage. In this case, if you recall the Mechanical Turk UI, so you get to drag on the passage to identify the answers from the passage of all the paragraph. So we have other questions. This one is related to the year, and this is about the ethnicity and the year again, and like home country, geographical locations, and some short phrases. And this, what you're looking at is the training data. So after we train the model on these 100,000 data sets, then we have a system that can perform question answering. So because this is my first time to Melbourne, so I go to the Wikipedia and grab a few paragraphs about Melbourne and paste it into my systems. So the model is trained on the other Wikipedia dataset you have seen. In fact, it doesn't include the Melbourne page. So I just paste this data in as a test set. So let me try to ask some questions. So remember, it can only answer questions related to this context, this few paragraphs. So let me see. Maybe I ask about the populations. Yeah. So what is the populations count in Melbourne? And the answer should be 4.6 million. Okay, so we can extract the numbers well. So maybe ask something else. So okay, maybe ask about this Melbournian. So what are the people living Melbourne known as? Okay, so there's, if you can see, there's no words living in the paragraph. So basically, understand inhabitants is basically it has some sort of semantic understandings, and later I will explain. Maybe just give you a high level overview. Okay, so maybe I ask another questions about. Okay, so actually, it was expressed me Melbourne was the host city for the Summer Olympic Games. Maybe I try to find out when was Olympic hosted in the city without specifying the name Melbourne. See whether you can figure it out. Okay, 1956. Okay, so maybe this time I'll try to identify someone, a person. So maybe I pick these questions. Sir Richard Polk, which give the name Melbourne to Melbourne. So who gave the name Melbourne to this city? So it is able to associate who. In this case, you are asking for a name or a person, entity. So you extract the answers from here. Yeah. Okay, so beside short answers, you can also extract long answers. Maybe ask something like, okay, so maybe what are the oldest cultural institutions can be found in Melbourne? So it's supposed to retrieve these few institutions back. What are the Melbourne's oldest cultural institutions? Okay, the Melbourne Cricket Ground, National Gallery, etc. Or anyone in the audience want to ask any questions? Yep.
What is interesting about Melbourne?
Okay. Okay, I have no idea whether you can answer or not. What is interesting about Melbourne? You surprise me if you can answer. Okay, maybe you will not find it interesting, yeah, but maybe interesting for the bot. Because the bot like humans, so the most populous city. Yeah. Yeah. Okay. So later we can play around with the demo further. I mean during the Q&A. So let's go back to the slides. Okay. Yeah. So basically, well, so what we done at the back is basically we built an end-to-end trainable model that allows the collaboration between the different layers and the network that read through the documents to have internal representations of the documents, conditions, or the questions input that is trying to answer. So basically, we have this character level embeddings, which is trained on the character level corpus. Then we have a word embedding, which is trained on the word level corpus. Then we have a context layer that to build the internal representations of the whole thing. So, okay, so yeah. Okay, so maybe in the past week, you've probably seen some news on your Facebook wall about Facebook. There's a Facebook robot, which is supposed to be very dangerous, and is something like Skynet, because it invented its own language. And Facebook was so panicked, and they shut down the program or the model. Okay. Okay, relax. In fact, they haven't invented Skynet yet. Okay, so yeah, they are not panicked. Yeah. So what actually happened is that Facebook is developing AI agents to perform negotiations. While they are trained in plain English, the researcher didn't create a reward mechanism for the bots to stick to the way that humans speak in natural language. So they invented a language themselves because it's more efficient, which the robot thinks. So yeah, basically they become creative and invent their own efficient way of negotiating a deal, which seems nonsensical to humans. So we have Alice and Bob here, and they have 3 books and some hat and a ball. So Bob say, I everything else. Ball have 0 to me. Seems like Alice won the ball very desperately. Yeah. So the agents, the model got shut down, not because they become dangerous. It's because the researchers. The bot got shut down because they are supposed to talk like humans. So in this case, human couldn't understand, and obviously we can't negotiate with the bot if they speak it like this. Yeah. So yeah, they shut it down. Yeah, I think all those reporters, they hide it out because before this there was this argument between Elon Musk and Mark Zuckerberg. So yeah, they just ride on the hype and try to spin something out. Okay, so yeah, back to my company Pandai, we just celebrated our first anniversary last month, And we have launched 2 chatbots with 2 clients. Okay, so this is what we learned, a few short lessons. So the first one is user acquisitions is simple, but it's not user retentions. So for user acquisitions for consumer, just put in more marketing dollars. For enterprise, it's easier. You just get someone higher up to force people to sign up to the chatbots. But for user retention, right, to actually make them use the chatbot, you need to engage them continuously by adding in more contents, or putting in like gamifications, try to make the whole conversational UX more fun. Then user expectations. So because when the users or general public, they heard of machine learning, AI, they would think that it knows everything. It's connected to the internet, it's supposed to read from Wikipedia and connect to all databases. And this is the impression they got from Hollywood movies. But in fact, so we need to set the right expectations. Like, okay, this chatbot is a customer service chatbot. It's supposed to only answer questions related to the product inquiry or to check on their policy in case of insurance. And the third one is content co-creation. So it's important that we work closely with our client to create the content or the knowledge base of the chatbots, because the content and the knowledge base will determine how smart or how knowledgeable your chatbot will be. Yeah, okay. We are hiring software engineers and community managers. Yeah, so feel free to drop me emails if you'd like to find out more about the positions. And yeah, so I'm open to questions for the audience.
Thank you, David. Do we have any questions?
Oh, do we have questions to the QA system or me?
If your intelligent agents have questions, feel welcome to ask them as well. Only if they don't say just to me, to me, to me, to me, to me, to me.
So one of the questions I have is, how do you handle new contradictory information? So suppose you had trained your chatbot on like your company's policies, and then you introduce a new policy. So you've got, how can a chatbot like that understand that it needs to like invalidate its old information, and like how does it just keep the useful old information but update only the new revised information?
Okay, so currently we still involve human inside. So in this case, the human need to get rid of the old outdated information from the model, and we just retrain the whole model on the new informations. Yeah.
Hi, just a quick question about out-of-core learning. So what advances are there for allowing the chatbot to go out and find new information? So you've got the question answering system there where you give it a context. How can we train chatbots to go out and find new information?
Okay, so for new, the training process will still be the same, just that maybe over time you're adding in more and more data if the developer came across. So what's your questions about? Is it like how do we integrate new data sources or?
So let's say we don't give the chatbot data, but we give it, say, access to Google or something like that. So it gets a question that it hasn't, on a topic it hasn't seen before. So it has to then go and identify where new information is. And then from that point on, it's pretty straightforward because it's the same process. But that sort of idea there of going out and finding new information, is there anything on that front?
Okay, so for our case, right, we are working with enterprise client, and usually the data we have is mostly in-house data. So, but I think for your case, like maybe a public-facing chatbot, you like to have the chatbot that learn on itself, so you get access to all those new pages in Wikipedia and just put it into the training process and hopefully learn more about the new stuff. It is possible, yeah.
Do we have any other questions?
Thanks for your talk. Just a quick question about the chatbot. If it gets asked a question that it cannot possibly answer, how can it tell that its answer is not right?
Okay, so when the chatbot in the inner working, right, for each answers they think is suitable, they have a certain confidence level. So we have this threshold. It's same like the machine learning model. We have a probability. So for us, right, we fully set like you only give out this answer if you are like 90% sure. If not, just sorry, I couldn't understand.
One last question.
Hi. So I have two questions, one for you and one for the chatbot.
Okay.
So for you, for your current customers, how long does it take to train? And if say, would it be feasible for them to add new data every day and run overnight a training session, or does it take too long currently in terms of processing?
Okay, so it takes around, let me see. The turnaround time is 1 week. Again, it depends on the data, how big is the data set. So usually it's like less than 1 week, able to do a batch updates on the model.
Okay, so you could do like a weekly data dump and have answers the next week.
But again, we need to validate the performance and before we roll it out.
And for the chatbot, what makes Melbourne a nice place to live?
What makes Melbourne a nice place to live? Oops. Okay. Oh, because it's huge. Yeah. So it's a nice place to live because, 9,900 kilometers square.
So having broken the chatbot, I think we might leave it there. Can everyone please give a big round of applause to David?
Thank you.
And on behalf of the organisers, may I present